start.
Greetings, everybody. We are Team Impactors. Harshit is the team leader, and I am Ishmael. This is our prototype, and we're going to brief you through it. Our problem statement is: how might we become the trusted guardian of digital integrity by educating the public on the risk of harmful AI algorithm and delivering cut-edge, accessible tools that protect vulnerable communities from algorithmic misinformation in real time. We will be able to verify whether a news plot is fake or true using this prototype, and we are going to brief you through it.
Yeah. So thank you, Matt. So this is the first one. We are doing the import of all the modules required in the prototype. So we are using the pandas, NumPy, Seaborn, sklearn for algorithms, and the regular expressor and the string modules. So we are using the locally hosted 2 months of data uh, based on news data. So it is fake news and true news. So we are importing using the read CSV pandas module. So what we are doing here, we are making the data fit. Okay. So we are ranking the data. So we are cleaning the data. We are shaping the data. So whenever you
We
got
have
the
created
class, like
we have created two
data
classes.
class, yeah. So whenever the class data is fake, you will be returning with 0 value. Whenever the data is true, you will be getting the 1 value. So let us start with the data analysis. So firstly, we are heading, like heading print the 5 data sets, top 5 data sets of the both. So what we are doing, heading 10 and all we are doing. So we are adding top, we are merging the columns of the two data sets based on the common values. So we are merging and shuffling it. You can see here. Now, using the regular expression, you are searching, sorting, and putting the string operation on data sets. You can see after that, you are training the data. So you are done with the data modeling or data analysis. Now you need to go for data modeling and data fitting. So for data modeling, you need to transform the data into the regular fit operation of X-train and X-test. So you get a training and testing data fitting to this model. Okay. So we have imported the logistic regression method, which is the linear graph method of training a data set. So you need to fit the data sets, the XV train and Y train into the linear regression model. And we are giving with the output of a linear regression model. So when you predict the data of XV pressed, so on this model, so you'll get a score of 0.986, which is really cool. It is 98.6%. The data is precise to 0.99, the recall function and all. F1 score is 0.99. So similarly, we are doing for second one also. So we are using the decision tree classifier. So whenever you are using the decision tree classifier, you need to use the XV train and Y train data. So you are returning with a algorithm model of decision tree classifier where you predict the XV test data, which gives you an absolute value of 0.9948. Okay. So it is 99.48%, and with a precision of 0.99 for false data and 0.98 for true data. And the F1 score is 0.99 for both. So for the third one, we are using the gradient boosting classifier. It is a classifier techniques where each each node is having a its own function. So you are fitting the data, the same data you are fitting, and predicting the values for XV test. It gives a really best result, which is 99.5%, really higher. And the precision values of both is 0.99 and 0.98 respectively, but the F1 score is 0.9 each. Similarly, we are doing for a random forest also. So random forest classifier give you it's a tree-based classifier technique where the each of the data is connected to the host local, like the tree, the main tree. So this data model give you a score of 98.8%, which is relatively better. So based on the four models, we are predicting whether the given news entered is true and false. So let me create a function which will tell whether the data entered is true or false. Okay. So suppose like I need to test the data. So suppose I'll click here. Now let's test some data. So let's go to some data. So let me open the data models.
We're using
This is
a
yeah.
sample of data to check to verify whether it is true or false. We can use any sample data. We've taken a recent data from the news, which we'll be able to tell if it's true or
So
false at
it
the
is the
end of
fake
the.
data. We already know. So when you put inside the testing phase, you will be checking it. You're getting it a phase fake news in all the scenario. Suppose what I am doing, I'm not writing the whole thing. I'm just writing from here to this one, the Pope. Okay. So this one I am writing. I'm running it. What are you getting? It's like it's a fake news. Still, a part of data is also considered as fake. Okay, because it's trained actually. So actually, the problem is all the real data is real, else all the data is false. Guys, this is the data modeling of the true ones. So let me make it. Yeah, let me get some data for the true one. So suppose this is the true data. True data is this is, and suppose we put it here, the true data. So it will be getting not a fake news in one of the case, which is the best one, the random forest one. But the all the three are giving a it's a true news. 1 minute. I'm
Yes.
telling you, like suppose if we give a bigger data, because we haven't given the whole data to him. Suppose we need to give the whole data. If you're giving the whole data, we'll be getting the whole data is not a fake news. So this is the whole model we trained. We are flagging data based on the fakeness and the real value of the data, whether the data is really well, true or false.
Correct or not.
So yeah,
So our
correct.
four models, if even one of the four models tell that it's a real data or the sample data is real, it shows the best accuracy. So if you input the entire data set instead of using a smaller sample, then we're able to analyze that for all sets, for all data types, sorry, for all data models, we're getting the correct value.